What's up guys, and welcome back to the Calculus Stories channel. Now in this video, we'll go ahead and take a look at the process that we have to get through to finding the derivative of cosine of x. Now, we'll go ahead and use the formal definition of a derivative to show that the derivative of f of x is equal to negative sine of x. And so remember that the formal definition of a derivative is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x, all divided by delta x. And so to go ahead and use this definition, let's go ahead and find first what f of x plus delta x is. And so f of x plus delta x is just cosine of x plus delta x. Now this form doesn't help us too much unless we go ahead and use trig identities to go ahead and expand it. And from trig identities, we know that cosine of x plus delta x is equal to cosine of x times cosine of delta x minus sine of x times sine of delta x. So now that we have that, let's go ahead and use the formal definition of a derivative to go ahead and find the derivative of f of x. So the derivative of f of x is equal to the limit as delta x approaches 0 of cosine of x times cosine of delta x minus sine of x times sine of delta x. This is the f of x plus delta x part, minus cosine of x, which is our f of x, all divided by delta x. Now, let's go ahead and move some things around, and through simplification and manipulation, we'll go ahead and get a form that's going to help us as we take the derivative of f of x. And so the first step that we're going to take to manipulate this expression is just move some terms around. And so we'll have the derivative of f of x is equal to the limit as delta x approaches 0 of cosine of x times cosine of delta x minus cosine of x minus sine of x times sine of delta x, all divided by delta x. Now, let's go ahead and use fraction properties to go ahead and decompose this fraction into two individual fractions. And so we can go ahead and write the derivative of f of x is equal to the limit as delta x approaches 0 of cosine of x times cosine of delta x minus cosine of x, all divided by delta x. This is our first fraction. And we'll go ahead and have minus sine of x times sine of delta x, all divided by delta x, our second fraction. Now, in our first fraction, let's go ahead and see if we can manipulate that fraction and factor out a common term. And so we'll go ahead and write the derivative of f of x is equal to the limit as delta x approaches 0. And from our first fraction, let's go ahead and see if we can factor out a negative cosine of x. Now, you'll go ahead and see why this is useful in just a moment. And so by factoring out a negative cosine of x from the first fraction, what you'll get on the inside is 1 minus cosine of delta x, all divided by delta x, minus sine of x times sine of delta x, all divided by delta x. So we haven't changed anything to our second fraction just yet, just our first fraction. And so now that we have this form, let's go ahead and see if we can go ahead and rewrite our fractions as a product of two fractions. And so we'll have the derivative of f of x is equal to the limit as delta x approaches 0 of negative cosine of x times 1 minus cosine of delta x divided by delta x. And so notice that the multiplication between these first two terms, negative cosine of x, and 1 minus cosine of delta x over delta x, is our first fraction. And then to express the second fraction as a product of two other terms, you can go ahead and write sine of x times sine of delta x over delta x. And so these two terms are the same thing as our previous fraction. The only difference is they've been written separately to go ahead and help us as we find the derivative of f of x. Now, using limit properties, we can finally begin to find the limit of each of these expressions. And so you'll have the limit of negative cosine of x as delta x approaches 0 times the limit of 1 minus cosine of delta x over delta x as delta x approaches 0. And so that takes care of the limit of our first fraction. And then you'll have minus the limit of sine of x as delta x approaches 0 times the limit of sine of delta x over delta x as delta x approaches 0. Now, it is at this point that we're going to use some limit identities to go ahead and help us reduce this expression that we have. And so the first limit identity is the limit of sine of delta x over delta x as delta x approaches 0 is just 1. The second identity that we'll go ahead and use is the limit of 1 minus cosine of delta x divided by delta x as delta x approaches 0 is 0. And so using these identities, we'll go ahead and be able to simplify the limit expression that we came up with. And so the limit of negative cosine of x as delta x approaches 0 is just negative cosine of x times the limit of 1 minus cosine of delta x over delta x as delta x approaches 0. From our limit identities, we know that that is just 0. And then you'll have minus the limit of sine of x as delta x approaches 0, it's just sine of x, times the limit of sine of delta x over delta x as delta x approaches 0. And using our limit identities, we know that that's just 1. And so simplifying this expression, when you multiply negative cosine of x times 0, all you get is 0. Minus sine of x times 1 is just sine of x, which just simplifies down to negative sine of x. And so the derivative of f of x, which is the derivative of cosine of x, has been shown to be equal to negative sine of x. So in my next video, I'll go ahead and show you guys how to find the derivative of sine of x using the formal definition of a derivative. So until then, see you guys later.